Hey guys, Mr. Decker here. This is Unit 3, Lesson 12 on sprite movement. We are moving right along, starting to get into some of the really good stuff where we learn how to make our sprites really move. In the last lesson, we learned how to make them wiggle, rock back and forth, shake around, that sort of thing. But now we're going to learn how to really make them move. So our computer science standards, there are a lot of them in this lesson. Create clearly named variables that represent different data types and perform operations on their values. Design and iteratively develop programs that combine control structures, including nested loops and compound conditionals. Decompose problems and subproblems into parts to facilitate the design, implementation, and review of programs. Incorporate existing code, media, and libraries into original programs and give attribution. Systematically test and refine programs using a range of test cases, and documenting programs in order to make them easier to follow, test, and debug. Our essential question today is, well, how can we control sprite movement in GameLab? And we're going to find out. So this lesson is on code.org, so make sure you're signed in over there with your school Google account. Your grade for this lesson will be based on your programming in the lesson on code.org. Watching the video is mandatory, yada, yada, yada. You know the drill. There's no need to submit anything on this assignment page. All work for this assignment will be completed on code.org. So no comment necessary, no need to say, I'm finished, I completed it, or anything like that. Just, I will check on your progress over on code.org. I'll put your grade in on Canvas. It will translate over to PowerSchool. Everybody will be happy, as long as you do your work. Okay, let's head over to code.org. You can click the link. I've already got the tab open. We're in Unit 3, Interactive Animations and Games. Let's get over there. And we're going to have to scroll down all the way down to Lesson 12. Bubble 1. All right. In this lesson, you're going to learn how to control sprite movement using a construct called the count pattern, which incrementally changes a sprite's properties. After brainstorming different ways that we can animate sprites by controlling their properties, we're going to explore the counter pattern in Code Studio, using the counter pattern to create various types of sprite movement. So let's continue. All right, Bubble 2, the counter pattern. This pattern is one of the most important ones in all of programming. So the counter pattern, right, this purple block usually indicates that we're messing with a variable, right? And so this variable says x equals x plus 1. What does x indicate? X usually indicates or is talking about x position. So if we're saying x gets x plus 1, what we're saying is, and we're running this over and over and over again because it's inside a draw loop, what we're saying is, with this particular piece of code, if that's inside of a draw loop, then we're saying x gets x plus 1. And if it's reading that over and over and over again, well, it's going to change the position of the object that's connected to that so that the x is procedurally getting higher every time that's counted. And since it's counting this 30 times a second, well, it's counting 30. It's going to be x plus 30 every second, basically, if you're doing the math in your head. It's used to increase the value of a variable by 1. You might call it a counter pattern, since it can be used to make a variable that counts up. You'll use this pattern a lot, especially with the draw loop. Let's see what that looks like. So do this. It says, this program creates a variable counter and then uses the counter pattern to make it count up. When you run the program, what do you think you'll see on the screen? So let's read the program and make a prediction of what the output will be. Then we'll run the program to check our prediction, and we will discuss what we've observed. So let's take a look down here. We've got a variable called counter, and it says counter equals 0. Then we've got a draw loop here. The background's going to be white. The text size, well, will be associated with the counter up here. See? So text size is related to this variable. The text counter x0 y400. What could happen? Let's think about this. And 1 second, I'm getting an interruption. I will be right back. All right, sorry about that. I am back. So let's continue to talk about this code down here. So we've got the variable counter equals 0. So counter equals 0. That means that basically the number, the variable equals what? What is it? 0. Okay. So the function draw loop, right? It continues to, the computer will zoop, 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 read it over and 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 over again at a rate of 30 times a second. So the background is going to keep being redrawn 30 times a second as white. The text size is going to be related to this variable. So the text size starts out at 0, right? So you're not going to be able to see it. And then text counter 0400, so that we know that's down here, right? 0x 400y. So whatever is showing up on the screen, the number that shows up on the screen is going to show up down here in the bottom left corner of our display area. And then this variable, right? This counter tied to this variable. So when it starts, it's going to be equal to 0, where the computer read this once. But remember, the computer reads this part once, and anything in the draw loop, it reads it 30 times a second, unless you use that world.framerate block to change the speed at which the computer reads the draw loop. Now, counter gets counter plus 1. So 0 plus 1 equals what? Well, 1. So now when it gets down to this, the computer now knows that counter equals 1. And it's going to go back up to the top of the draw loop, draw the background white again. It understands that the text size is linked to this. It understands that the text counter is at 0400, so it's still going to be down here. And then it's going to add plus 1 to it again, so it'll be 2. Run everything again, background white, text size counter, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? And it's going to keep counting and counting and counting. And since the text size is related to the number, then I'm predicting that the text size is going to go up. The location of the number is going to be static. So the bottom left of the number is always going to be here, despite the fact that the number is going to procedurally get bigger as the number itself gets bigger. So it'll get taller and wider in pixel size as the number increases. So the number, or the value that appears here, should be equal to the pixel height. So I'm thinking that the number is just going to continue to get bigger and bigger and bigger in size, like physical size, as the number gets bigger in value. So let's type this out. The counter variable tied to the counter size will increase rapidly as the computer cycles through the draw loop over and over again. The number counter will appear at the bottom left corner of the display area. And that might be all I need to say. The counter variable tied to the counter size will increase rapidly as the, okay, yeah. So the value of the counter will increase as the size of the counter increases. I hope that makes sense. Okay, let's run it and check to make sure we were correct. Oh yeah, okay, cool. So basically the number is increasing at a rate of 30 per second via size and value. We can finish and move on. Now we've got a video to watch. Animate with sprites.
You can animate with sprites too. To do this, you'll need to update their properties inside the draw loop using the counter pattern. For example, this program creates a sprite called mySprite. Then, inside the draw loop, it uses the counter pattern to increase the sprite's X position by 1 in each frame. This makes the sprite move smoothly across the screen. Adding a second sprite to a program is easy. You just use the create sprite command again. This program animates 2 sprites called Sprite 1 and Sprite 2. Sprite 1 uses the counter pattern to move across the screen by adding 1 to its X property. Sprite 2 moves down by adding 1 to the Y property on each tick of the draw loop. These sprites have lots of other properties, but our program only needs to deal with the ones that are changing. Sprites already help you write more readable programs, and they are going to be extremely helpful and powerful tools for making fun games and animations. So stay tuned.
All right, as you can see, we're starting to really cook with gas here. So let's move forward. Bubble 4. On sprite movement. Using the counter pattern, you can write programs that animate sprites smoothly. Adding to or removing from a sprite's X or Y property in the draw loop makes your sprite move just a bit each time it's redrawn. Do this. Read the code that makes the jet go up the screen, and add code that makes the plane move to the right, as in the sample image. So over here, we've got a plane that's moving up the screen. So it's starting down here at 400Y, and then its Y value is decreasing, and that's what's making it go up the screen. If it started up here, we would want to do what? We would want to add to Y. To go up, we subtract from Y. With X, we're going to be adding to Y to move it to the right. With X, we're going to be adding to X to move it to the right, subtracting from X to move it to the left. So let's run it. Right now, right, as it moves up, you can see its Y value goes down. I'm going to reset, run that again, right? You see that Y value going down at the bottom of the display area? That's what I'm talking about. So we've got to increase the X value. You see the X value going up as my cursor goes across? Okay, so let's go down here. Our variable for the jet, create sprite, set animation is correct, variable plane, all of this is set up for us. And then we can see how jet.y gets jet.y minus 3. So let's learn how to build this, because there are steps to it. So we need to go to the sprites drawer, and we're going to do sprite.x, put that here. Let's reset this so I can see what I'm doing. Hold on just a second, getting a phone call. And we're back. All right, phone call just took a couple minutes. So first thing I want to do is match this variable to the plane, because that's what I'm trying to get to move across my screen. And it won't influence the plane unless this variable is tied to this one. So now we need to go to the math drawer. I told you there were steps to this. We want to grab the plus numerator. And then I'm going to go back to the sprites drawer, and I'm going to grab sprite.x again. But when I put it in here, it won't have this purple block, right? It's just going to be little. And I need to match it again. So now it's plane.x equals plane.x plus. Now the jet, let's go up here and see what speed it wants to move at. So the jet's moving fast, kind of fast. The plane seems to be moving a little slow. Now we can play with the speed. So if I do 1, this is its speed. Just changing the position every time that draw loop is reread by the computer. Now I can make it go faster by increasing this. Let's try 7. Now it speeds across, right? So you're kind of picking up what I'm dropping, but we want to match this for the sake of the lesson. So 3. Yeah, that's the speed. All right. So now let's do some more of this practice. Bubble 5. Moving to the left. If adding to a sprite's x coordinate makes it move to the right, how could you make it move to the left? Do this. Make your program animate like the image to the right. Update fly.x inside the draw loop so that in each frame the fly is drawn a little bit further to the left. And you see that happening up here. Moving from the right side of the display area to the left side of the display area. And there's a tip here. You can make your sprites move faster by adding or subtracting larger numbers. The fly in our example moves about twice as fast as the plane in the last level. So if the plane was moving at 3, the fly is moving at, 6, since it's moving twice as fast, right? Okay, let's make this fly move. Right now, he's just sitting there hanging out. So we need to go to our sprites drawer, sprite.x, match the variable, math drawer. We're subtracting this time because we're going from the right side to the left side. And you see how the x value decreases going that direction, increases going this direction. So since we're moving left, I want the subtract operator. I'm going to go back to the sprite drawer. I'm going to grab sprite.x again, match the variable, and then put my value here of 6. So this fly, when I run this program, it should go across the screen to the left. See? Now, if I throw this away, go back to the math drawer, add a addition operator, sprites, sprite.x, match the variable, add the number, what's going to happen? Well, the fly is going to disappear backwards, right? Because now I'm adding to x. So remember that. That's very important. When you're adding to x, you're moving your sprite to the right. When you're subtracting from x, you're moving it to the left. And with y, if you're adding to x, if you're adding to y, you're moving it down. If you're subtracting from y, then you're moving it up. So let me fix this again. Math drawer, operator, sprites drawer, .x, match the variable, 6, fixed. And then if you really want to go high speed, right? But there is a hard upper limit to that. So if I choose like a speed of 50, zoom, 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 right? It's kind of too fast. 100, let's see what happens. Barely even see the thing. Shoom, shoom. So for the purposes of the assignment, we'll leave it at 6. Buzz, buzz. All right. Moving on to bubble 6. Diagonal movement. Updating both the X or Y properties of a sprite can make it move diagonally. You can use the watchers under the code area to see how each property is changing. We've got watchers down here. Find my cursor on the screen with your eyes. I'm moving it down here to the bottom right. Here are your watchers. And the watchers will show you what X value equals and what the Y value equals. Do this. Read the code and make the mouse go down. Or read the code that makes the mouse go down, sorry. Run the program and look at the watchers to see what is happening to the mouse.x and mouse.y properties. Okay. Well, mouse.y is increasing as the mouse goes down the screen, but mouse.x isn't changing at all because the mouse isn't moving across the screen, he's moving down the screen. Add one more line of code that makes the mouse move diagonally. Run your code again and look at the watchers. So to make him move diagonally, well, we need to do a mouse.x. So sprite.x, match the variable, math drawer, adding 2x because we're moving from left to right, Back to the sprite store, sprite.x, match the variable, and add in our value, which will be 2 in this case, because we want those to match. Now he's moving diagonally, just like in the picture up here, and we can see our watchers are increasing both the x value and the y value. And those values keep going up. So as far as the computer is concerned, it's redrawing this mouse way over here as it's moving down still. It's still going up. But our display area is only this big, 0 to 400. And that's that one, right? Challenge, set the sprite's rotation property so that it faces the direction it is moving. So let's do that. Let's make it face the correct direction. So right now it's kind of weird, right? He's kind of sidestepping it a little bit. Let's set his rotation up here and see what happens. Equals 45. Whoop. Oh, it typed over there. I see. Mouse.rotation gets 45. Run. Oh, nope. I don't want to do that. Let's try something else. Let's try 45 wouldn't be 90. 120? Nope. Now he's facing the exact wrong way. So let's try like, what would be the correct number here? Negative 45? There we go. So as you can see, you kind of have to play around with these numbers a little bit until you get the number that will work directionally for the direction that your object is moving or your sprite is moving. It might take you a second, but just think through it. You'll get there. Now, what happens if I were to put mouse.rotation into the draw loop? What do you think? Nothing. It does the same thing, right? The computer only needed to read it once, but if it reads it over and over again, that's fine because you're not telling it that the rotation property changes. You're just telling it this should be the rotation property over and over and over again. Bubble 7. Read the program and predict which of the following animations will be produced. Okay. So red car rotation equals 90. Yellow car rotation equals 180. Blue car rotation equals 270. Green car has no rotation, so I guess it just naturally faces the way it's going to face. And then in the draw loop, we've got red car dot x equals red car dot x plus 4. So the red car should move from left to right. So let's find an answer that shows the red car moving left to right. C shows it moving left to right. But let's check. Okay. Yellow car dot y plus 4. And we remember y, as the number increases, you're moving down the screen. So C works for yellow car. Blue car dot x minus 4. So blue car should be moving left, and it is in C. And green car dot y minus 4. So the green car should be going up. Yep, C. And I'm pretty sure we're right. We are. Cool. All right, so try out using the draw loop with these activities. So let's make this pan spin. Make sprite spin with the counter pattern. All right. Rotation and spinning. Using the counter pattern on a sprite's rotation property can make it spin around. Do this. Use the counter pattern with the pan sprite's rotation property to make it spin as in the image on the right. Okay. So up here we've got our pan being created, but it's just sitting there perfectly still. The draw loop is drawing the background in that pale green over and over and over again, and it's drawing the sprite over and over and over again. Now, if I pull draw sprites out, what's going to happen? It's only going to be a background because it's only drawing the sprite once and then drawing the background on top of it 30 times a second. Now, if I do that, still only the background is being seen over here because it's drawing the sprite before the background. Remember that the order in which the computer reads the code is very important. So let's go to our sprites drawer. Let's make this thing rotate. So we've got sprite.rotation. Let's match the variable. If the variable doesn't match, just watch pi. Okay? What's going to happen? Let's increase the rotation. Back to the sprite drawer. Grab this again. Let's match it there. Pan. +3. Run. Oh, we've got an error. Oops, we can't figure out what pi is because, well, there is no pi variable set up here, so pi isn't going to do anything. But I fix it to pan to match this variable, and it rotates. We're rotating a little faster than they wanted us to, apparently. Let's try 1. It seems like the speed they want. All right, and then let's try a different number. Let's try 15, see how fast it rotates. Much faster. Let's try 50 and see how fast it rotates. Oh, yeah. And then let's go big. Let's try 200. What? Okay, yeah, that's kind of funky. So anyway, let's change it back to 1. Oop. Control Z is my friend. All right. There, 1. Run. There we go. Finish. Continue. And I think we'll be on B, watching the counter pattern. Fix the direction of the motorcycle by looking at the watchers. Okay. So when I run it, oh, did you see that? Run. You just see the motorcycle right here for like a split second. Boop. Run. Okay, so let's see what we need to do here. This program should move the motorcycle from the bottom left to the top right, as in the image up here. However, the motorcycle moves off the screen too quickly to see what's going wrong. Do this. Look at the watcher for cycle.x. Add a watcher for cycle.y. Okay. So let's add a watcher for, let's see, how is that doing? Cycle.x. So we want .y. It's undefined. So run it. Not available. Let's see. Maybe I can name it cycle.y. Add that. There we go. Run it. Not available. Oh, I see what I did wrong. Boop. Add cycle.y and just leave it at that. I didn't need to add the colon apparently. Cycle.y. Run. Okay. So the y value, let's pull this up a little bit. Maybe you can see that better. The y value is increasing, right? Well, if we want it to move up, the y value needs to decrease. So to fix this, we need to pull that code out. Control Z that so that everyone can see what I did. I put my cursor right here, not on the 10, not on cycle, not on the Y. Whoop, Control Z again. I put it on the plus so that I could grab that whole thing and pull it out. So cycle.y gets back into the sprite, or back into the math drawer, sorry, and we want to subtract. Back to the sprites drawer, sprite.y, and that's important, right? If you were to say like cycle.y equals cycle.x, it's going to get all jankied. It's going to get messed up. I saw a lot of that problem last year when I taught this unit. Students kind of got mixed up with putting an X here and a Y here, or a Y here and an X here, or whatever, right? Let's run it. Now our motorcycle is going the correct direction, on a diagonal up, right? So if you want it to move at a diagonal, you need to influence both the X and the Y. Now, what happens if these numbers are different? See, the angle changes. The angle at which it moves. Let's try 40, right? Seeing how that is influencing how it's going, because now its Y value is decreasing faster than its X value is increasing. So that influences the direction that it travels and the speed at which it travels as well. Oop, Control Z. Goodness. All right. So 10 and 10 to match so that it goes smoothly up into the corner. Finish and continue. Let's do rotation direction. Make the gears rotate together. Rotation direction. When you use the counter pattern for the rotation property with addition, the object will always rotate clockwise. Sometimes, however, you will want your sprite to rotate the other direction. To do this, you can just use subtraction. Do this. There are 3 gears set up for you. You need to make the gears all look like they are rotating in sync with each other. Make the gears rotate so that they look like they are working as one system. Hint, they won't all rotate the same direction. So let's run it. All right, so I think if we run the red one clockwise and the green one clockwise, we should probably run the blue one counterclockwise, and that will look natural, like we've got some gears working the way we want to. So up here in lines 1 through 8, we're just getting our gears onto the screen. And then we draw them on the screen down here in the draw loop. All right, so let's see here. Let's go to Sprite drawer, sprite.rotation. Let me reset. Let's give ourselves more room to work. Sprite.rotation, sprite.rotation. So we've got blue gear. And I actually want to do them in order that they appear on the screen. So I want to do red gear, camel case, of course, and then blue gear and green gear. So it's not in the same order as it is up here because I want it to be in the same order that it's in on the screen, because that's what makes sense in my head. All right. So now I'm grabbing math operators. I want my red gear to move towards the right. So I'm adding to its rotation. I want my blue gear to move to the left, so I'm subtracting. Green gear will move to the right, so I'm adding. Now, back to the sprites drawer, sprite.rotation, sprite.rotation, sprite.rotation. I need to match all these variables. Red gear. And if you want, you can Control C, Control V, Control C, Control V instead of typing that out. Let's try 1 to get started. So now we've got functioning gears, and you can see the blue one is cranking both the red one and the green one. So let's increase our speed. But if we increase the speed of one, right, without increasing the others, it kind of messes up what we're visually going for. So we want all these numbers to be the same. That is really satisfying to watch. Now, if we increase that number, right, every time, they're all going to spin faster. Super satisfying to watch. And if we were to take the background out, what happens? Whoa. Now they're like spinning discs, right? So Control Z. Oop, Control Z isn't doing anything for me. Oh no, what do I do? Well, we go back to the drawing drawer, put a background back in here. Finish and continue. And we're done with these practice levels. So let's move on to bubble 9. A fish animation. This icon means that this level is part of a larger project. Changes will be saved across these levels. Good to know. Always good to pay attention to that. So it looks like we're wanting our fish to move to the left, but it looks like we want them to move at different speeds. So using the counter pattern, make all 3 of the fish move as in the image to the right. The blue fish should move the fastest, and the green fish should have the slowest speed. So, okay. So all of them are set up here. Animation tab, you can see they were set up over here. Whoop. Let's make some magic happen. Okay, let's do some animation. So if I run this as it is, only the orange fish is moving. What we want, it said the blue fish should move fastest, and what else did it say? Green fish should move the slowest. And they're all moving left. So, sprites, and we're influencing their X value because we're moving them left or right to left, rather. So, blue fish and green fish, remembering to use camel case. And then math operator, we want the subtraction because we're moving right to left. Or we want not just a math operator, we want the subtract operator. I'm not sure what I said there. All right, let's see. And then we want to go back to the sprite drawer, sprite.x, sprite.x. Make sure you don't accidentally grab sprite.y, match the variable label, Control C, Control V, Control C, Control V. And then it said the blue fish should be the fastest, so we'll make him the fastest, and then the green fish should be the slowest. Right? Blue fish the fastest. Yep, green fish the slowest. Very good. Reset run. Reset run. And it looks like okay, I see. So their X or their Y position, their starting position changes within these ranges each time. That's cool. I didn't pick up on that the first time. Finish. Continue. Bubble 10. We've got some challenges. More fish. Make the fish wiggle as they move. Okay. This was the A challenge. More fish. Before you learned the counter pattern, you learned to set sprite properties such as rotation to random values to animate them. By setting the rotation of the fish to a random number, you can make them appear to wiggle slightly. This will make their movement animation more lifelike. For each fish, randomly set its rotation inside the draw loop. To make it look as realistic as possible, choose a small range of negative and positive values. Makes sense? So down in the draw loop, sprite.rotation, sprite.rotation, and sprite.rotation. So we need to match the variables. So orange fish, Control C, Control V, blue fish, Control C, Control V, and green fish, Control C, Control V. And then math, random number, random number, random number. Pretty sure I'm doing this right. So let's do -3, whoops, -3 to 3, We'll have the blue, the blue fish is a little bit faster, so let's do -5, 5. And then the green fish is the slowest. He's not moving very fast, so -1, 1. And that's just to make it more realistic, right? Because the blue fish is moving fastest, so he'll be really kicking. The orange fish is moving less fast, medium fast. Yeah, sure, that's the term that people use. Medium fast, medium speed. So the blue fish is high speed. He's really kicking. Orange fish, medium speed. He's kicking a little less. The green fish is barely kicking at all. He's just kind of lazily getting through the water. All right, continue. Bubbles. Use the ellipses to make bubbles rise to the surface. That'll be fun. Bubbles. You can also use the counter pattern to animate shapes such as rectangles and ellipses. Since this is an underwater scene, let's try to create a bubble that floats to the top of the screen using an ellipse shape. If we use the counter pattern to update the Y value of the ellipse, we can make it seem like it's floating to the top of the screen. This is cool. I like this. All right, do this. Create at least one new variable to keep track of the changing Y position of the bubbles. Okay. Set the value to 400 or another number near the bottom of the grid. Use no fill, stroke weight, and ellipse to draw at least one bubble. Use the variable you created to specify the Y position of the ellipse. Use the counter pattern with subtraction in your variable to make the ellipse slowly rise. Okay, what code goes above the draw loop? Just the variable you create. So, So we need to draw this ellipse, and it's going to have to be drawn over and over and over again because it has to be drawn on top of the background. And did they show us what it needed to look like? I think they did on the prior screen. Let's go back. Back button. They did 3 bubbles. Okay. We got this. We can do this. All right, let's see. Let me pause for a minute. All right, we're back. Okay, so let's dig into this. So the first thing it wanted us to do is create at least one new variable to keep track of the changing Y position of the bubbles. So up here, outside the draw loop, and it gives you this hint here, what code goes inside the draw loop, what code goes above the draw loop? Well, the variable. So let's do variable. We'll put it right here. And since we're working with bubbles, we'll just call this bubble Y because we're working with a bubble and we're changing its Y position. And since we're starting down here at the bottom of the screen, let's just go ahead and we'll set it at 400. So every time the program is ran, the bubble's Y position will be 400. Okay, so down here, we need to draw the bubble. And we need it to draw it over and over and over again, so it always appears on top of our background. But I kind of want my fish to swim in front of it. So first thing we need to do, let's see. Let's grab, we're making a bubble, so let's do no fill. Pop that into line 21 there. And then we will do, let's do stroke, color, and instead of blue, let's do white, so it'll stand out a little bit. It said stroke weight somewhere, right? Stroke weight. But that's not an option, so we've got to add stroke weight. To add stroke weight, we're going to have to click Show Text. And put your cursor at the end of line 22, hit your Enter key, start typing stroke, select stroke weight. And for stroke weight, let's do 2. And then I'm just using my arrow key in there, and I need to put a semicolon here. If you don't put that semicolon, you're going to mess up your whole program. All right, so let me show you how I did that again. Show the blocks, show text, enter down from line 22, start typing the word stroke, click on stroke weight, type the number 2, put your cursor out here, semicolon, back to show blocks. Here's our stroke weight block. Okay. Now, the next thing I want to add then is my ellipses. And they did 3 of them, so let's do 3. In the sample on the last page, anyway. Now, I don't need all of this out here. I don't need to mess with the height of it. So, because if you put just a random number right here, like let's say a bubble the size of 20 pixels, right? If you've only got one number here instead of 2, then both of these numbers are 20. Let's do 30 for this bubble. We'll do 25 for this bubble. Their X position, I want to be different. Let's do 125. Let's say, let's do 215 for this one, just off center. And the X position for this one, let's do 329, whatever, right? And then if I run this, here are my bubbles, but we need to get them all started down here. So 400, 100, 100, and that should move them all down here. And then I need to tie their movement to this variable. So to do that, we need to go back to the variables drawer, grab an x equals, not a variable x equals, but an x equals. We'll put that here. Match the variable, bubble y, using camel case. And we're going to say equals, and we can grab our math operator. We want the subtraction one. And we're going to say bubble y minus 1. And that should, in theory, move them up the screen. Actually, no, it won't yet because I haven't tied the ellipses to it yet. So they're just going to sit there. So now their y position should be, let's see, bubble y plus, right? Maybe just bubble y right here. Because that should say, okay, when it starts, it will be 400, and then it will subtract. So yeah, so let's put bubble y here. Let me grab it. Control C, Control V, Control V. Now they should go up. There we go. All right, but now they're like all in a row. So how can I fix that? Let's do some math. Because I kind of want them to go up at different intervals. So maybe if I do, let's see. Let's pop that in there. Let's pop this in here. And we'll say bubble y. Bubble y plus 35, and let's say plus 20. Let's see, run. Yeah, there we go. So now they're kind of at a slightly different level, because now what I've said is I want bubble-wise this bubble starting position to be even further down by 35 pixels. I want this bubble to start at 400 plus 20. This one's still starting at 400 because I didn't add anything to it. But I can mess with these even more. So let's say 50 for this one, right? So it should come up last. See? And that's my biggest one at 35 at pixel width or height of 30. Very good. I like it. Cool. So setting up the variable for bubble y out here, applying that variable in here to each of the bubbles, and then setting up what I wanted to happen with that variable inside the draw loop down here to make the animation. I am happy with that. Let's finish and continue. And I guess that's it. So if you want to do the free play, you most certainly can, but that's it for this lesson. I hope you had a good time with it. I know this one was a little long, but sprite movement is a big deal for everything that we're going to be doing moving forward. Literally a big deal for everything we're going to be doing moving forward. Making your video games, making your animations, all of that. Sprite movement is huge. So make sure you understood literally everything about this lesson. I know I went through it a little slowly and a little detailed, but I really want to make sure that you are getting all of this. So thanks for hanging in there.